Yes. So we're talking about the building our own stack, right?
Mm-hmm.
So stack has two properties, your push and pop, correct?
Yes, sir.
Push is always, I'll call it as ST push, okay? And I'll call it as ST pop because pop as a function we have, but yeah, let's call it pops, doesn't matter. Okay. So push is always at the like last, okay,
Yes.
and pop is also from the last, right?
Yes.
So we'll create a class called stack, okay, and of course you have to define the init, right?
Mm-hmm.
Okay, and we'll call this as stack only. Okay, so you get a blank stack. Now we need to learn how to push and pop. So when we do push, okay, we need to add a value, isn't it?
Mm-hmm. Can we just
And
append it? That no, append doesn't work for this. Does it?
so see, so it depends, right? Like what do you want to do, right? Now see
Yes.
what I have designed, I have used self stack as a list,
Yes,
isn't
sir.
it? So if you use self stack that as list, then we
Mm-hmm.
can append it.
But if it's linked list, you can't. Okay.
No. See, everything that we have discussed so far and we're going to discuss in future,
Yes, sir.
everything is based on those four things only,
Yes, sir.
right? What are those four things?
List, dictionary,
Sets,
sets,
okay,
and tuples. Yeah.
tuple, right? And see, tuple doesn't allow us to edit, so tuple is generally only for printing. Or okay, so we only need to know three things. Okay,
Mm-hmm.
okay. What did we use for linked list?
List, sir. Right.
Yeah, how did you save the data?
We save the data as
So so in linked list, okay, since we have
hmm.
to have two values,
Yes, sir.
okay, we did not use any of the data structure.
Okay, okay.
We use direct class and object. So we saved values in class and
Yeah.
using that object. Okay,
Yeah.
so object can, you see, object can have multiple values, isn't it?
Mm-hmm.
Okay, list can have only one value, but your object can have multiple values. So we used object to handle our linked list thing. Okay, now here since we have simple, okay, or you can even use here also, you can use as a separate class an object, okay, but then object will have only one here. See here, okay, in stack we don't have adding at the end, adding at the beginning, and adding at the middle, right?
Mm-hmm.
You don't have concept of removing at the middle, removing at the end, removing, okay, in between, right? You don't have those things. So if
Yeah.
you don't have those things, we don't need to use the way we handle a linked list. We can
Mm-hmm.
directly use list, and but we are managing the list through a class called stack. So for the user who's going to use it, okay, they will feel that this is a inbuilt class stack. See, if you remember when we were using it in linked list also, while calling, okay, while building, of course, we have to look at the complexity. That's the encapsulation part. But the user who's going to use your class, for them, it doesn't look like as if you are using a object or a list. for user it looks like if you are
Stack.
using inbuilt stack. There's something called as inbuilt stack. Okay, I'll show you what I mean here. So okay, so push, let's say for now, okay, let's add it, no?
Okay.
So how do we add? Okay,
Uh,
now we can directly say, okay, um self.
Since we're using a list for a stack, can't we use append to just push?
Yeah, that's what we're doing, no?
Okay, okay.
But see, from a end user perspective, it is
Mm.
push and pop. They know that stack has push and pop.
Yeah, yeah, yeah.
We are using append to add this value here. Okay, and
Mm-hmm.
then you say return. Now here you say def pop. Okay, and obviously pop you don't need anything. You
Mm-hmm.
say um, uh, 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 you would say self dot stack dot pop.
Oh, there's a
Pop,
pop built in.
right?
Oh,
There's a
okay.
built-in pop, right? Stack list has built-in pop and remove.
Okay.
Remove is for the element and pop is for the index.
Okay. Is there a built-in push or is it just append then?
No, append and insert.
Okay.
So append is always at the beginning, and your uh, insert is you have to give the index number as well.
Okay.
Okay, and then you say return. That's it. Now,
Yeah.
so this is what you have built,
Yes.
right? Let's say I have built this. Now I go to, let's say I go to P11.
Mm-hmm.
Okay, and in P11 I'll say import 2023.
Yeah.
I need to import 2023.
Mm-hmm.
Once I import 2023, I can create my stack, something
Mm-hmm.
like this, equal to stack. Okay, so I'll say import June 23 st or something.
Mm-hmm.
So now I'll say st dot stack. Okay,
Is stack the name of the class in that?
exactly.
Okay.
This is what we did, right?
Yeah.
Class stack.
Yeah.
So you say P11 class stack. And see, this is something that you have implemented. Okay, the user doesn't know what you have done, right? It is it's hidden from the user. Now you'll say stack equal to my stack dot push,
Mm-hmm.
right? So see, it has only two methods, push and pop,
Yeah.
nothing else. No insert, no update, no delete,
Okay.
right?
So just
So
do my stack dot push and you add like the user adds a value and then pop.
exactly. So my stack dot push, my stack dot push again, right?
Mm-hmm.
And now um, my stack dot pop. Okay, so you pop, you don't have to do anything. Okay, so now your stack is created, but how do I view? Okay, so see, every thing need to have view, isn't it?
Mm-hmm.
Okay, so we need to add another method here. We'll call it as display or something. Okay,
Okay.
we'll simply say display.
I'll just
So
build it. Okay.
yeah, here I'll say def uh, display. Oops, display, and this should return your entire stack.
Mm-hmm.
So self dot stack, correct?
Mm-hmm.
So now when I go back here, I'll say my stack dot display, right? Now let's put it after every operation so that we can see the status of the list. P11,
Mm-hmm.
P11. Oh, okay. Okay, so here we are not printing, we're returning, right? So if you want to print, you can print here so that we don't have to print there. Otherwise, we have to print it there, isn't it? So now you run it. You see, first 55, then 55, 75, and now you have only 55 because we
Yeah.
said pop. You don't do this the print here. Instead, we will do print here. Print, and here also print, and here also print. Makes sense? So you are able to do this. This is your stack. Now you can, what happened? I didn't push. It should not be push, right? It should be display, right? Okay. This is how you get. We haven't added any condition here, okay? And I want you to add that condition. So maybe
Condition
here,
like what, sir? Like, do
yeah.
you want to add? Do you want like that?
Sorry, what was that?
Like condition for the user, like.
No, here,
Uh-huh.
what if uh, what if there is no element to remove?
Oh, then we have to raise an exception, right?
You can raise an exception. You can give a print message. Okay, you can simply print message saying,
Yeah.
um,
There's no element to remove.
exactly. Okay, or you
Okay.
can return false, and then
Okay.
here you check if it is false. You say, so it's up to you how you want to handle it.
Okay.
Okay,
Yeah.
so that way, and here also, if empty stack. Okay.
If okay, sure.
Yeah.
Saying that if what's a list listed as again? Stack, right?
No, stack is listed as list. So
Oh
len
yeah,
of.
yeah, yeah. So if we say if self.stack is empty, like is null, then what's it called? Then we'll just return like
You
a
can
condition.
simply
You can
check the
say,
len, right?
oh, you can set length. Yeah,
Yeah,
sure.
because it's a it's a list
Yeah,
end of the day, right?
yeah,
You
yeah.
can say if self dot
Stack.
stack, is that right? So
No,
if
if
len of,
length of self.stack, right?
yeah,
If
correct,
length of self.stack is equal to 0,
right,
then we can just print the stack is empty. Please enter a variable or something.
correct. Okay, or simply print empty. Okay, because
Yeah,
we are doing we are checking for the empty list only. So
yeah.
you can do that. All right. Okay. Now, let's talk about um, queue. Okay. So we go to class queue, and then we say def init. Okay, and I say self dot queue, right, equal to, we can say list here, right? And then what we do in queue, we say add, right? So or queue is add and remove, right? So we can say add a value, right? And for now we'll say pass we'll come and build later.
But
Then
add a
we'll
value finished. No, we can't do that.
I'm just creating the structure here. You
Okay.
can always, yeah. So def, um, def, um, okay, def, then add remove, right?
Yeah.
Remove, and remove again we don't need because it is always the first element to be removed.
Yeah.
And then we say display, something like that, right? And we'll say pass here as well. Now let's go and add values to each of these.
Yeah.
Okay. Now, okay. So there's one more thing here you can do in push, and same thing we can do it in add. Okay. Do not accept duplicate values. Okay.
Okay.
It means, see, when you are in the queue, you cannot
Mm.
again come back in the queue. You're already in the queue, right?
So for
So it's
that, we
like
can like iterate throughout the list and we say if the
you don't
variable
even
that you
have to
want.
iterate. We have this in membership operator.
Yeah. If I in this
Yes.
don't. Okay. Okay.
Right. So
Yeah.
if I come here, okay, and I'll say if, okay, value in our self.queue,
Mm-hmm.
something like this. If value is here, then we can say um, print this value is already in queue. You are already in queue, something like that, you know.
Yeah.
You don't have to enter, and we can say return, and then we can continue building here.
Mm-hmm.
So here we can say something like self dot q dot. Now you see this element, okay, should be added in the beginning itself, isn't it?
Yeah.
So you can say append. Directly you can say append. Done. So add
Mm-hmm.
is done. Now remove. So remove again, you can add the check.
Mm-hmm.
Okay. If value. Oh, okay. So we don't know the value, right?
Yeah.
So we have to get the first member from the yeah you know, so not the first member, right? It's not specific value. We are
Why can't,
removing.
sir, I have a question. For
Yeah.
remove, for like
Mm-hmm.
queue, for the previous one, we just, for stack, we just said remove of -1, right? Index
Correct.
-1.
Here you will say 0. That's it.
Yeah,
That's
that's
the
it.
only
No.
difference.
Yeah.
Exactly. So I'm just checking the condition here. If len
Oh,
of
okay.
q greater than 0, then we'll say self dot q dot um, pop, and here it will be 0, not -1. Else you can print message. Okay,
Mm-hmm.
q is empty. Okay, now display, we can simply copy and paste what is there here. Now this is an example. Okay, pop display. Okay, this is example where, okay, we could implement a parent class for stack and queue.
Yeah.
Okay, and we can give this display as common for them, right?
Mm-hmm.
So I can create here class. Okay, so that's your task. Let's do that. Create a, okay, I'll say assignment here. Modify this program.
Okay.
Create a parent class for both stack and queue. So it will be like, you know, class my data structure, my DS,
Mm-hmm.
and then you have to add push. Now push and pop. Again, see, names are different. So we can't do that here. You can implement display here. And when we call stack.display, this display should be called.
Mm-hmm. Okay.
Okay. And implement display function here. Okay. So you don't have to do 2 times display. So we can put display here. Of course, here it is queue, not stack. So we'll change this to queue. Okay. Now, if you go back here and let's try to, okay. So, so you're calling, this is the alias for the file name or module name. Module name is June 2023. Module name and file name will be same, isn't it?
Yeah.
So we have this, and so we say stack.queue. Now we are building for queue, right? And let me call it as my queue. So your my queue, my queue, my queue, my queue, my queue, my queue. And here you'll have, instead of push, we are saying add. Correct? Add. And for pop, we are saying remove. Are we saying remove? I think so. Right? Remove.
Yeah.
Now we have display. Now when you run it, so now you see in stack, 55 is left, 75 is removed.
Yeah.
In queue, 55 is removed,
Yeah,
75
removed.
is left.
Yeah.
Okay. Okay. Now to talk about the last topic, okay,
Mm-hmm.
before we get into advanced structure like hash and binary, it's
Yeah.
your DQ thing.
Mm-hmm.
1 second. DQ, we'll go back to here. DQ is your, okay, just like we have double-ended linked list, okay, Q
Mm-hmm.
is your double-ended queue.
Okay. Then why does not use linked list? Why Dequeue?
See, why we can use list also for linked list, right? Now,
Yeah, but
all
I
this, no,
yeah,
I'm coming to the answer.
yeah.
See, everything is interconnected, okay? Their job is to store data,
Mm-hmm.
but they have some inbuilt logic into it, okay? So in linked list, you can remove and add anywhere,
Mm-hmm.
right?
Yeah.
But in queue, you can only add at the end and remove from the beginning.
Mm-hmm.
So you do not have delete like in list. You know, when deleting, you had to ask which value you want to delete,
Mm-hmm.
right? Here
Yeah.
you will not be asking which value to delete. So your DQ is a special implementation of linked list.
Okay.
So here you will, so exactly same thing, okay? You can copy and paste the same code here. And
Mm-hmm.
in fact, you have to remove 2 things from here. One, when in the when you are adding the value, you will only add at the end by default.
Okay.
So you will not check whether it is adding to be done at the first step or middle step.
Mm-hmm.
You will simply add, follow the logic for adding at the end.
Okay.
When you're removing it, you will not ask which value you want to remove. Silently, you will remove the element at the first.
Okay.
So you can assume DQ as a subset of your linked list.
Mm-hmm.
Linked list has all the features and DQ is just special way of implementing list.
Mm-hmm. Okay.
Okay. So you will only add, okay. And so we have inbuilt DQ. In the latest version of Python, they have implemented some additional features, okay?
Mm-hmm.
Like one is like your DQ, okay? So we don't have to implement like linked list. We can simply call, okay, it is in collection. So you say import collections and you say collections, okay, dot dequeue. Okay. Now if you say queue, right? Okay, yeah. Dequeue. Okay. So dequeue is already there. Now I will call this as, let's say, dequeue equal to collection dot dequeue. Now you can add the initial list of values here. Okay. So let's say if I want to save as, let's say, names equal to Sachin, Virat, okay, Dhoni. Let's say I want these names to be the default names in the beginning. So you can say names. So now you'll have a dequeue with these names. Okay. Now you want to see the properties of dequeue. Dequeue dot append pop. See, append takes a value. Pop takes a value. Clear is to remove, clean all entire thing. Exactly. Then you have extend to add to dequeue. You have taken two queue and you put them together.
Okay.
Doubly ended. Doubly ended means, see, single ended queue. Doubly ended is DQ. That's why we say DE. DE stands for doubly ended. So if you want to remove from left, so you say pop left.
Okay.
Okay. Insert at a specific value. Count the number of X. Very similar to what we have in list and other, right? Index. So you give the member, it'll give you the index at which index. So are you in the queue? It'll tell you, where you're in the queue. Remove is to remove the element from the DQ. Copy is create duplicate copy. Reverse will reverse it. Append left. So by default, it is to the right. Okay, append and pop is from the right. Append left, pop left, extend left is for adding at the left. Okay, so if I say pop, okay, and if I print DQ, okay, so from the right, okay. Okay, okay. I should move it to the P11. You're talking about P11 now, right? So you run it. So you see, from the right, Dhoni is gone. Okay. Now if I say DQ dot pop left, print DQ.
So pop is just like default right, and then pop left is left. Okay.
Correct. Sachin is gone. Okay. DQ dot
Does
append.
only only DQ has this like property of like pop left, not like is stacker queue?
No, stack and queue is, see, that's why it's double ended. Double ended means you can do operation from both the ends.
Yeah, okay.
Right? Stack queue is only from one end.
Yeah, okay.
Right? So DQ is a special implementation of queue where you can add and delete from both the ends.
Yeah.
Okay. All right. So this is how you implement DQ. Okay. So you can also create what is called as doubly ended, or not doubly ended. It's anyway, it's ended. Double linked list, right? So double linked list will have 2 pointers.
What? Oh, okay.
Right? Double linked list will have.
Oh, so from the previous one to the next one to the previous one also.
Exactly.
Okay.
So let me go to paint now. So a typical node in a linked list will appear something like this.
Okay.
Okay. So you have value and you have what we call as pointer to the next, something like next pointer. And your double linked list will be something like this, and you can have one more box inside this. Okay, so it'll have three values. So when you declare node, last time we declared self dot data, self dot next, and this time you will say self dot previous also. So this is your value. Okay, and this is your next, and this is your
Yes.
previous. This is called double linked list. So every time you have to do one extra step. That's the way to link your um, pointer to both the ways. Okay. Now you see, if I'm adding, I will not implement it. You try this on your own. Okay. And tomorrow we'll see it. So what happens? Okay. So let's say, you are talking about a double linked list here. Okay. You're talking about double linked list here. Now, when okay, so let's say these are connected. This way, this way, this way, this way. Now, if I have to add something at the beginning, you have to add something at the beginning. So when you have the single linked list, okay, if you have a single linked list, we did nothing. We just said it's next equal to this. That's all.
Yeah.
It's next equal to this, and this is anyway the first one. Okay, this becomes first. But when you talk about double linked list, you have to say this equal to this, and this next equal to this. This is the extra step that you have to add.
Yeah.
That's it. If you were to add something in the between these two, so you will break this link, put it here, and this link to here, which is anyway you will do in double linked list also. But you will also bring this link and put this link here and this previous to the here.
Yeah.
So previous breaking this and putting this is also an extra. Same class that we took. You extend that class. Okay, you add you say double linked list, DLL. And when you are adding at the end, what we did, we simply took this and added this connection, because this is anyway by default it will be null. But here there is no none. There is no null, right? Okay, of course this next null will be there, but this previous should point to not this.
Okay.
Okay.
Yes.
So if I go back to our program, okay, so we'll go here and we'll say class double linked list. Okay. And of course, class we won't give it because we are not inheriting. Def init. Okay. And okay, and if you want to add data, you can have data or value. Then here you say self dot data equal to data, self dot next, right, equal to none, and self dot previous equal to none. Now this is when you create a standalone
Just piece of the
double
link.
list. Yeah, right. And now when you do add, remove, or display, you can do it.
Yeah.
When you're doing display, okay, so here you will also have head and the last. Okay, so in display, you could do both ways display. In the previous link list, okay, so major change in the display also, traverse. So traverse was only from left to right.
Yeah.
In this case, traverse will also be from right to left.
Okay.
Okay, so you can ask, left to right, LR traverse, RL traverse,
Mm-hmm.
right?
Yes,
So
sir.
create def LR traverse, okay, and you will have def RL traverse. Or what you can do is, just like they have done in Dequeue, you have only traverse, and traverse by default will be left to right. Okay, and for other one, you say reverse traverse or backward traverse,
Okay.
back traverse, something like that. So the main names are generally left to right, and if you want to do something right to left, you have to go from right to left. Okay,
Yes.
so yeah, we'll stop here, and if tomorrow if we don't meet, I mean physically,